Okay. I hope we have an introduction yesterday. What we have done, just we will touch like upon that. Uh, Actually, my name is Shiva. So I have 8 years of experience in industry. I work on multiple technologies: AWS, Docker, Kubernetes, Jenkins, Terraform, Shell script, Python, Java, Spring Boot, like multiple Groovy as well. And I hold AWS Developer Associate and Certified Kubernetes Administrator and Terraform Associate certifications. This is my profile, and we have seen the general introduction and the whatever the prerequisite that you need to have before joining this course. Not much prerequisites, only one prerequisite is required, that is an AWS account. Okay, then the course introduction, like we went through the course and the syllabus that will be there as part of this course introduction. Okay, then if anyone is new today, please go through the video that will be there in the YouTube. Just go to the YouTube, and you can search for Docker and Durgasoft channel, and you can search for Docker and Kubernetes by Shiva. You'll get the demo one video there. Please go to that. It will be very clear for there. Just I want to give an introduction that I have given. So what is the next part? Okay, what is the next part? Next part is done. Want to I'll show it. So we are going to start this from scratch, and we want to understand the what is DevOps first, then what is an application, and what is SDLC, what is a server, what is physical server, what is Docker and Kubernetes, and where does Docker and Kubernetes fits in software release process. Actually, that are the concepts as part of introduction we are going to see, and then we will step into the Docker concept and Kubernetes concepts. Like first we'll go through the Docker and then Kubernetes. Okay, what is a DevOps actually? What is DevOps? DevOps is a combination of development as well as operations. Development means don't think that you need to develop an application code. You need to understand the functionality of the application, and as part of DevOps engineer, and you need to develop the scripts to automate the infrastructure and to automate the some daily activities with Python, whether it is Groovy or any language. You need to automate the things actually. That is the development you need to do in the DevOps. And the operations means the maintenance. Maintenance means if any updates you need to provide, if any version updates, or if any additional things you need to provide to the infrastructure. Infrastructure, what is the meaning of infrastructure? Some technical words I'm using. Let's explain that before. Okay, what is the meaning of infrastructure? What is infrastructure in our society? Is roads, lights, highways, and paths. These are the infrastructure for us actually. And then what is the infrastructure for applications to run in order to uh, run the applications? What is the infrastructure? Here, the infrastructure is servers. We need servers that in order to run that applications. That is the infrastructure. Not only the servers, there are many services, but we, as part of Docker and Kubernetes, we need servers in order to run the applications, in order to deploy. Run means deploy or put the applications on the servers. That is infrastructure actually. That is infrastructure. So we, to maintain the infrastructure, maintaining of infrastructure, like if any problem has been happened in that infrastructure, okay, that maintenance will be coming under operations. Okay, that maintenance will be coming under operations actually. So maintenance of infrastructure will be coming under operations. Developing scripts in order to automate our daily tasks will come under development. It is a combination of development as well as operations. DevOps is a combination of development as well as operations. Okay. Automation. Like, what is the meaning of automation? I hope most of the people know. Let me explain. Okay. What is the meaning of automation? Okay. Automation means like what example I can take. Suppose recently what we are going to do is in order to get a food from outside, we need to go to a hotel, and we need to order a food. We need to get the food, and get back to home like that. We need to do. But after the Swiggy and Zomato has come into picture, what we'll do, we'll just order a food in the app, and those people will get the food for us, and we'll get the food at our home. That means you have automated that process of getting the food from the hotel. You have automated that like Swiggy or Zomato has been automated the process of getting the food from the hotel to your home. That is automation. That means they did an automated thing. So that is automated. Like the daily tasks we do, if you automated, if you automated in some way, or using some technology or something. So that is an automation. So that is an automation. So development is part of automation. You will be developing the scripts, whether it is Terraform scripts, Python scripts, Shell scripts, or any scripts. Okay, that is to automate the daily activities. So that is automation. Okay, that is the development and automation. Actually, those are the development and operations. What is an application? Actually, next thing we have to discuss is about the application. Actually, what is an application? Application means it's a website. Like it's a website. Like whether it is Redbus, redbus.com or advenced.com, like that. This is a website. Okay, so just nothing. Application is equal to website. That's the meaning actually. Application is equal to website. That's the meaning actually. So it's a website. What is an application? Application is equal to an website. Application is a website actually. So in order to develop this application, how the industry develops these applications. Develops means how the industry creates this application. How the industry creates this application. So industry follows some methodology, like we have different methodologies. Famous one is SDLC and the agile methodologies. So they will follow this methodology, SDLC, software development life cycle methodology, in order to develop the applications. We are not responsible for developing. Okay, the developers will be developing that application. So that is the process. This is SDLC process, software development lifecycle process. By they will be using that software development lifecycle process in order to develop the applications. Actually, that is SDLC. Okay, then what are the different phases of SDLC? So let's go through it actually. So analysis phase, actually that's a requirements phase or analysis phase. What they will do in the requirements phase is they will collect the requirements. How many people, like for example, how much time uh, this how much time is required to develop this application, how much amount of people are required to develop this application, and if the time is extendable, how much we can extend that time. Such kind of requirements, if such kind of requirements has been collected in that requirements phase, what are required in order to run that application. So such kind of requirements, so it is part of requirements phase actually. And next phase is design phase. Design phase, what is the design phase? Actually, design phase will, the application will be, we are not responsible for doing this. Why I'm explaining this is I want to explain the deployment phase. That's why I'm explaining all these phases. So next phase is design phase. Design phase is they will be designing the application, where the login and where the username and password in order to log in should look, where it should be in on the website, like whether it is on the top of the page or whether it is on the middle of the page, with the bottom of the page. There is a complex, there is a complex design phases. Like they will design entire application, like they'll follow some design patterns in there. We have different design patterns, structural, behavioral, and creation. That's a different concept. Okay, so we have design patterns. They'll use the design patterns and they'll design the applications. Actually, they'll design the applications in the design phase. Okay, that is the design uh, phase actually. Then what is the next phase? Next phase is the development phase. They will, developers in this phase will be writing the code, whether it is any code, backend code, whether it is Java, whether it is Spring Boot, or whether it is .NET, whether it is Python, any code. They will be using a respective code that suits their website, and they will be using that, and they will be developing the code, okay, for that application to run actually. So that is a development phase, and in the development phase developers also writes the unit test cases, okay. So don't worry what are unit test cases, that is not part of our job. So that is the developers will be writing unit test cases. They will be using some frameworks like Mockito, Format, and JUnit. So that's the, I want just you people just to know that those developers will be writing unit test cases actually using some frameworks, okay. That is part of development phase. And the next phase is the testing phase. Testing phase is there is a separate team in order to test our application, uh, developed by developers, okay. Those people will be testing that application, actually testing that application that developers developed, okay, like whether the functionality has been properly working or not, and if I give the wrong password, whether I am able to log in or not, if I give the right password, whether I am able to log in or not. So such kind of testing they'll be doing, and they'll be using some tools and technologies in the testing phase. We have some tools and technologies called Selenium. We have they'll be using that, and they'll be testing that application developed by developers actually. So that is testing phase. And the next phase is the deployment phase. Actually they will be placing the application on the servers. They'll be placing the application on the servers actually. There are different strategies we can follow, like we industry follow to place or deploy the application on the servers. So those strategies were comes under Docker and Kubernetes. Here is where, in this phase is where our Docker and Kubernetes comes into picture actually. So that is the deployment phase. This is where our Docker and Kubernetes comes into picture. Just remember, our Docker and Kubernetes comes under deploying deploying phase actually. Then maintenance phase. Maintenance phase is the maintaining the application, whether it is providing any updates or whether it is providing any security related things, and the version updates. So like that, it's a maintenance phase. They will be like in the maintenance phase, people will be team will be maintaining that applications actually. So if any problem occurs, they'll be solving that problem, such kind of things. That is maintenance phase. So this is the 6 phases of SDLC process, and our Docker and Kubernetes comes under deployment phase. Deployment phase, that is this phase actually, this phase. Okay. Next question. Next question is, what is a server actually? Server. So when you click on redbus.in, you are able to access this website. You are able to access this website from your browser actually. How you are able to access this website? That's the question actually. So how you are able to access this application means this application has been put on a server actually. This application has been put on a server so that you are able to access this application. Okay, any application, not only this application, any application in order to access outside. If anyone want to access from their browser, that application should be put on a server. That application should be put on a server so that the people can be able to access that application. That is an application actually. So that is a server actually. Server is an uh, is a hardware device on which we will be placing, or we will be putting our application, or we will be deploying our application in order to external, in order to people can use that application actually. That is server. That is server actually. So where is that? Is that, yeah. uh, so server is something called a machine, or a device on which we place our applications, we deploy our applications actually. So that is a server actually. So where does Docker and Kubernetes fits in SDLC process? We have already seen that. Somebody put something in chat. Okay, okay, okay. Yeah, yeah. So Docker and Kubernetes fits in deployment phase of SDLC process actually. So that is the question. That's the answer we got in the SDLC when we are discussing about SDLC. So that is part of SDLC, like deployment phase. Actually, Docker and Kubernetes comes under deployment phase. Okay, what's the next? 1 second. So deploying applications on physical. See, when it comes to servers, we have different types of servers actually. One is physical servers, one is virtual servers, and one is Docker containers. So we'll talk about Docker containers later. As of now, just think of physical servers and virtual servers. Okay, what are physical servers? Physical servers are devices. It will be looking like this. Okay, there are many physical, like it will be very large, very high amount of physical servers. So physical servers means the servers which we can touch and we can feel and we can interact with that are called physical servers. So see, if in the previous times or few years back, what the people used to do is they will be deploying their applications on the industries will be deploying their applications on the physical servers actually. What are physical servers? Physical servers, okay, physical servers, but the servers that we can touch or feel or interact on or deploy the applications are called physical servers. Okay, there are many disadvantages if we deploy the applications on the physical servers actually. There are many disadvantages if we deploy our applications on the physical servers. So let's discuss what are the disadvantages that we have if we deploy the applications on the physical servers actually. So let's discuss that. What are the disadvantages that we have if we deploy the applications on the physical servers? Let me discuss as part of diagram. Okay. Mm, Take a screenshot of this.
Hello, sir.
Hello. Yeah.
Yeah, Naveen here. Good morning, sir.
Good morning.
Yeah. Sir, I have a question, sir.
Okay.
My question is that why we need Docker actually, sir?
That's what we are going to discuss actually. So
Okay.
but what are the disadvantages that we have on the physical servers, how the virtual servers has come into picture, and what are the disadvantages were there on virtual servers, why the Docker has come into picture. So that is a process I'm taking you to actually. Okay, that's
Okay.
a
Okay.
question. That's the answer you will get at the end actually.
Okay. Okay.
Yeah. So this is the physical server. Let's assume this is a physical server, uh, and we have placed our application on this physical server. We have deployed our application on this physical server. So our application is properly running. No problem with that. Okay, I want to run disadvantages. Okay, this is a physical server. Let me write the physical server here. Okay, this is physical server. Okay, so what is a disadvantage here if we run our application on the physical server? Suppose let's think our physical server has our physical server has uh, 10 vCPUs, that means 10 CPUs, 10 CPUs, and 100 GB memory. 100 GB memory. This is the infra, like these are called resources in industry. So this much amount of resources are there. That means 10 CPUs are there, 100 GB amount of storage is there for this physical server. Okay, so if our application requires, if our applications my application here requires only 1 GB of memory or 1 CPU and 1 GB of memory, 1 GB of memory. Okay, so my application only require 1 CPU and 1 GB of memory. And the what is the remaining here? 9 CPUs are remaining and 99 GB of storage is remaining. So that is wastage, right? My application is running, that is required only 1 CPU and 1 GB of memory. And so 9 CPUs and 99 GB of memory were wastage. That means first, this is the first disadvantage. First disadvantage, that is resource wastage. Resource wastage. My application only requires 1 CPU and 1 GB of memory, but my physical server has 10 CPUs and 100 GB of memory, and the remaining 9 CPUs, one CPU and 1 GB of memory is used by my application. And what are remaining? 9 CPUs are remaining, and 99 GB of memory is remaining for the physical server. So that is waste actually. That is waste. That is left idle actually. So the, the first disadvantage when we deploy the applications on the physical server is the resource wastage. Resource wastage actually. I want to write it here actually. So I'll be writing here. Disadvantages of using physical servers. What is the first disadvantage is resource wastage. Okay, that is the resource wastage. Okay, I hope you understand this resource wastage. That means you see like one CPU and 1 GB only required by my application, but my physical server has 10 CPUs and 100 GB of memory. Then remaining 9 CPUs and 99 GB of memory is waste actually. So that is resource wastage. This is the first disadvantage. Okay, what is the second disadvantage that we have? Second disadvantage is, suppose my application is running on the physical server. Okay, this is a physical server, my application is running there, and what if this physical server crashes? What if this physical server crashes? That is a huge loss to the business. People will not be able to access the application. Okay, suppose let's think this application itself a Amazon.in. Okay, Amazon.in, and there is a sale tomorrow. There is a sale tomorrow. This Amazon.in application. Let's assume that this application, Amazon.in application, has been deployed on a physical server, and there is a Dasra sale tomorrow. Like suppose let's think a Dasra or Diwali sale tomorrow. What if at the time of the sale, if the server crashes? What if at the time of the sale the server crashes? Then it's a huge impact, it's a business impact for the Amazon.in people actually, for the Amazon people actually. So that is the second disadvantage we have. If anything happens to the physical server, then application itself will be down. Application itself will be down actually. That is the second disadvantage. Okay, so write that. Okay, this is the second disadvantage. And the third disadvantage is like, suppose only one application is there. That is, I have one application. Okay, I have deployed this application on the physical servers actually. Suppose, let's think I have 100 applications. I have 100 applications. In that case, what is the case? How you are going to deploy the applications? You need to have the 100 servers in order to deploy the application. So Each application requires only 1 GB of 1 GB of memory and 1 CPU, and on each physical server has 10 CPUs and 10 GB of memories, and your each application, 100 applications, or each application in 100 applications requires only 1 CPU and 1 GB of memory, and remaining 9 CPUs and 99 GB of memory is the wastage actually. Even though we have a wastage on each server, uh, we need to put 10 like 100 physical servers in order to deploy the 100 applications actually. That is the other disadvantage. Even though we have a resource in one server, we need to deploy multiple servers in order to run multiple applications actually. So that is a third disadvantage. Running multiple servers for multiple applications. So this is a third disadvantages. So, what is the next disadvantage we have when we deploy, when we put our applications on the physical server? The next disadvantage is like we need to maintain these physical servers. Actually, we need to provide the team, separate team to maintain these physical servers, to provide the security updates, to regularly deploy the applications on the physical servers, and to regularly monitor the physical servers, whether it is a CPU monitoring, memory monitoring, and whether it is any metrics monitoring. You need to regularly monitor a physical servers, and you need to provide a big room to put that, to place that physical servers, and you need to have an air conditioners, you need to you need to have a power supply, and there is a this is a huge maintenance that we need to do if you put your applications, if you deploy your applications on the physical servers actually. That is a fourth disadvantage that we have if we are using physical servers in order to put in order to deploy our applications actually. So fourth disadvantage is, what's the fourth disadvantage is maintenance problems, high maintenance, I can say. High maintenance and high maintenance and this requires high maintenance actually. That is a fourth disadvantage. And what is the next disadvantage? Next disadvantage is, in order to run 100 applications, we require 100 physical servers actually. So that is the next disadvantage. We have already discussed that disadvantage, but if we want to run in 100 physical servers, we need 100 physical servers, and there will be a huge cost if we buy 100 physical servers. Okay, so that is the cost is the next disadvantage. Okay, cost. Okay, we need to spend more cost, like more money, in order to buy multiple physical servers actually. Cost. Okay, this is the next disadvantage. So we have multiple disadvantages like this. So that virtualization concept has been evolved actually. Virtualization concept has been evolved actually. So because of these disadvantages like resource wastage, application downtime, and running multiple servers on for multiple applications, and high maintenance and cost. So because of these disadvantages, and there are many more, like we will be coming through that reasons when we discuss about the microservice architecture. So there are many more disadvantages. So as of now, these are the main disadvantages let's think of. And because of these disadvantages, virtualization concept has been come into picture. So let's go to our slides. Did everyone understand these disadvantages? Any questions, please, here? Any questions, please?
No, Shiva, clear.
Yeah, thank you. And let's go to the other thing. What is virtualization? What is virtualization? Virtualization means creating multiple machines on one machine. That means, so I will be explaining you in a diagram. So, so suppose this is my physical server. Physical server, we have discussed what is physical server up to now. This is my physical server. This is my physical server actually. So this is my physical server. What are the disadvantages we have if we deploy, if we put our applications on the physical server? We have seen just 5 minutes, 2 minutes before. So what the industry did is they have invented some concept called virtualization. You can see it in a diagram here. Okay, virtualization. Okay, then what upon this physical server, what it will be there actually is in the physical server they have installed anyway there will be an operating system that will be running on the physical inside the physical server. Let me write it here: operating system, whether it is Windows, Linux, or anything. But to deploy the applications, 99% of the companies or 95% of the companies uses Linux operating system. Okay, so let's think it's an OS operating system. Okay, this is an operating system that will be there inside the physical server, top of the physical server. And then what is the next step? To create a multiple, like we will think of like why we are discussing this. We will be getting clarity after this concept actually. So what they did is they have installed some virtualization software on the operating system. Actually, there are different virtualization softwares that are present in the market, like hypervisor and Oracle VirtualBox. Such kind of virtualization softwares or multiple virtualization softwares available in the market. What is a virtualization software and why it is required? We will see. Let's, as of now, there is a virtualization software they have installed on the operating system. Let's think like that. VirtualBox, VirtualBox, actually, VirtualBox. Okay, this is a virtualization software. What this virtualization software does? What is the functionality of this virtualization software? What's the functionality of this virtualization software? Means what the virtualization software does is this it will create multiple servers on one physical server. Actually, this is a physical server upon which this is a physical server upon which we have installed operating system, upon which we have installed VirtualBox, that means virtualization software. And then what does VirtualBox does is what we can do with VirtualBox software is we can create multiple machines on the one physical machine actually. Okay, this multiple machines we can create on one physical machine. Okay, like this we can create. Okay, these machines are called virtual machines. Okay, so these machines are called virtual machines. So I can put the name here. This is VM. We will call VM1. We will call like this, and VM2. and VM3, VM4, virtual machine 4, virtual machine 5. Okay, let me write it here. VM refers to virtual machine. So what the industry does is they have only one physical server, upon which the operating system will be there, whether it is Linux, Windows, or anything, and they have installed virtualization software such as VirtualBox on the operating system, and this VirtualBox software, virtualization software, is used to create multiple machines on one physical machine. That means it can create multiple machines on one physical machine. Those machines are called virtual machines. Actually, virtual machines. What are virtual machines? Virtual machines, the machines that we cannot touch and feel, we can only interact with that machines through the command prompt, through the commands, is called virtual machine. Virtual machine. Okay, virtual machine is the machine that we cannot touch and feel, and we can only interact with that machine through the command prompt using commands, is called virtual machine. I'm explaining in a simple language. There is a like huge definition is there if you see, but in order to understand well, I am explaining very simple language, so that we cannot touch and feel, and we can only interact and we can execute commands and using command prompt, is called virtual machine. Actually, that is virtual machine. Did you understand the virtual machine concept, please? Because this is a concept. Slowly we are entering into the Docker. Please, if you have any questions, please ask. Any questions, please? Any questions? Did you understand? If no questions, just reply that you understood. Anyone?
Clear, Shiva. Can proceed.
Yeah. Thank you for that. These are virtual machines actually, because so we have seen some disadvantages if you use physical machines in order to deploy the applications on the physical machines, and then in order to rectify that disadvantage, what the industry does is they have installed a virtualization software on the on the physical server on the operating system, like VirtualBox, and have created a something called virtual machines on top of one physical machine. So what are the disadvantages of using physical virtual machines? We have seen the disadvantages of using physical machines, physical servers, physical machines entirely is same actually. So this is the virtual machine actually. So suppose there is an application one, I have been deployed app one, and suppose I have deployed my application 2 here in the second virtual machine, and I have deployed the application 3 on the third virtual machine. Okay, so what is the disadvantage here actually? What is the disadvantage here? So that means, I can say, like, if this first virtual machine has the same disadvantage that has for the physical server is also there for the virtual machine, virtual server. Okay, so I have 10 GB, 10 CPUs for this virtual machine and 10 GB of memory, 10 GB of memory. Okay, so for this virtual machine, and my application only requires 1 GB of memory and 1 vCPU. Okay, it requires only 1 GB of memory and 1 vCPU. Let me write it here. 1 GP of memory, 1 CPU, 1 vCPU, and 1 GB of memory required for my application. What about the remaining 9 CPUs and 9 GB of memory? That means resource wastage is there. Resource wastage is there. Even though cost is less, even though we can deploy multiple applications on one physical server using virtual machines, even though cost is less, but the resource wastage disadvantage we have seen previously as part of disadvantages of physical servers is also there with virtual servers. Actually, this is the disadvantage. That means resource wastage is the disadvantage of using virtual machines, actually using virtual machines in order to deploy our applications on the virtual machines. Actually, if we deploy our applications on the virtual machines, resource wastage is the disadvantage. Okay, so here is where, in order to rectify this disadvantage, Docker has been come into the picture. Actually, Docker has been come into the picture. Actually, so what does the Docker does actually? So let's draw a virtual machine here that will be on the physical machine. I'm drawing like a big one. Okay, this is a virtual machine. Let's see. Okay, 1 second. Uh, this is a virtual machine. Okay, inside the virtual machine, there will be operating system. There will be operating system, and top of the operating system, what the industry did is they have installed Docker. Just I will be drawing that. Docker is a container runtime engine. I'll explain what is Docker. They've installed Docker. What this Docker did for us, why they installed Docker, what this Docker did for us is we can run multiple applications like in one virtual machine itself. So like this, app one, I can run app two, I can run app 3, like that. Multiple applications can be run on a single virtual machine. So if suppose the same 10 CPUs and 10 GB, 10 CPUs, 10 GB of memory is there for my virtual machine. First application is using 1 GB and 1 CPU, 1 GB and 1 CPU. And second application is using 1 GB and 1 CPU. And third application is also using 1 GB and 1 CPU. So these applications will be using the resource properly actually. So we can deploy multiple applications on the virtual machines actually, not in case of this virtual, like on the virtual machine. In case of, if you don't use Docker on the virtual machines, you can run only one application and there will be a resource wastage if you run one application. And if you run multiple applications on the virtual machine, there will be a no resource wastage. The left out resource will be used by another application, and the left out resource will be used by another applications. Like that, you can run multiple applications until and unless the resource is properly used, actually, until and unless your requirements are met. Actually, this is the way of deploying multiple applications on single virtual machines is achieved by container runtime engines. One of the famous container runtime engine is Docker. We have multiple container runtime engines in the market. One is Docker, one is ContainerD, one is Rocket, and so there are multiple one. But the Docker is the famous one that is popularly running in the market. So Docker is responsible for running multiple applications on a single virtual machine for the proper resource usage. So that is Docker. Yeah. Any questions here, please? Naveen, you have some questions. Did you get the answer?
You mean to say, sir, Docker, using Docker, we can able to run the application across different environment, right?
Yes, yes. You can run the applications on different environments, and you can
Okay.
run multiple applications on single virtual machine also for proper resource usage.
Okay. Okay. Fine.
Yeah.
Sir. Got it.
Yeah. Any questions, please? Any questions today? Any questions before going off today? Okay. Let's summarize what we have discussed. We have discussed about the DevOps and the explanation, and we have discussed what is an application. We have discussed SDLC process and where does the DevOps like Docker and Kubernetes fits in SDLC process. And we have discussed the server, what is server, and we have discussed this one, where does the Docker and Kubernetes fits. Actually, we have discussed about the physical servers, and we have discussed about the disadvantages of physical servers, and we have discussed virtualization, what is virtualization, and virtualization is something but creating multiple machines on one physical machine, that is virtualization. Those are called virtual machines. And we have discussed the virtualization architecture, how the virtual machines are created upon one physical machine, actually, that is virtual machine. And we have discussed, we need to discuss about the cloud. We have not discussed about the cloud. We have discussed how the Docker has been evolved and why the Docker has been evolved, because the disadvantages of the if we deploy the applications on virtual machines, we have some disadvantages. That is why Docker has been evolved in order to proper resource usage on the virtual machines. So this is a summary, and if you have any questions, please go ahead and ask. And if you don't have, let's continue tomorrow. Any questions, please? And please go ahead and register for the course in the DURGASOFT website. Yeah.
Hello.
Hello. Yeah, tell me.
Yeah. Whatever we are discussing the theory part, that should be provided by note or anything.
Yeah, it will also be provided by note, and we will be discussing in class. Yeah.
Yeah. Like what is Docker? That part you discussed. That we are discussing, but we later we forget. So that's why I'm asking.
Yeah, that will be provided in the notes clearly. No problem with
Yeah.
that. That will be provided.
Okay. That's thank you.
Yeah, and let me tell that I think up until this Friday is the last days for the demo. From Monday, we are going to see the live classes. Please go ahead and register in the course. Yeah. Yeah. Any questions? If not, we can drop off.
Thank you, Shiva. We'll meet tomorrow.
Yeah. Thank you.